So welcome to the talk. The devil is in the details, hidden problems of client-side enterprise Wi-Fi configurators. This is a joint work with my colleagues and my advisor over at the Chinese University of Hong Kong. So for enterprise Wi-Fi, usually it is using EAP for mutual authentication to log in to the Wi-Fi. And popular phase 1 methods uses TLS or SSL, that's another name, to authenticate the server, and then to establish a secure tunnel. And after the secure tunnel has been established, some password-based method can be sent inside the tunnel. So that's also known as phase 2. And for server authentication in the TLS, usually it is done by digital certificates. And in order to authenticate the server, you first need a chain of trust that originates from some trust anchor. And also your leave certificate that you present to the client has to have the correct name in the subject or in some other SAN field in the certificate. And it is well known that there is a so-called evil twin attack, where an attacker can set up a rogue access point and spoof the SSID of a legit AP, and then the user may connect to the rogue AP, and the attacker can get the credentials. And the attack is very easy. It can be done with just a Raspberry Pi. And this is especially important because for organizations like companies, they use the same credentials for Wi-Fi login and other internal services. So if we get the Wi-Fi credentials, we are able to use that for to access other services in the organization. And so we can configure the security of enterprise Wi-Fi with the UI in like usual operating systems, but it's quite tedious, and relying on human users can lead to insecure outcomes, as we all know. And so there are the so-called Wi-Fi configurators that promises to make enterprise Wi-Fi connection easier by redesigning the UI or automating the configuration process altogether, and also possibly automatically checking for the server identity. And so our goal is to test all these so-called Wi-Fi configurators with our own evil twin setup. So there are 4 types of configurators that we consider in this study. So first, there is what's called a TOFU feature in Android. So TOFU stands for Trust on First Use. It's already quite an old concept, as you can see for OpenSSH. And it assumes that for the first connection, the public key that you got is secure and it can be remembered for future connections. This remembering is also known as pinning. But more commonly, instead of just blindly trusting the public key, it also requires the user to at least verify the server's identity for the first time, then after which it can be reused in the future. And the attacker goal in this TOFU attack is obviously to impersonate the server, thus reaching credential theft. And if possible, we also want to have a stealthy attack where the user can still connect to a legit setup afterwards, since the attributes are pinned, right? So that's also another goal, that we don't want the user to detect he's being attacked. And for Android, they introduced this TOFU feature for enterprise Wi-Fi. It's quite recent, since Android 12. When you first connect to an enterprise Wi-Fi setup, you will be shown a prompt showing some attributes of the server certificate, and you are asked to check the certificate and choose to accept or reject the certificate. If you accept, then certain attributes of the certificate will be pinned and remembered for future connections. And so we have found a few issues with the current implementations of this Android TOFU. So the first issue is that when the user first connects to enterprise Wi-Fi, the credentials are sent before the prompt is even presented to the user. So basically means that this prompt is useless. The attacker can already get the credentials even before the user has a chance to reject. And the second one is you can notice that the attributes of the highest level certificate means closer to the chain is shown instead of the leaf node, which is actually different from the documentation where the server name is shown. And this means that the attacker can spoof the prompt and makes the user believes that they are connecting to a legit Wi-Fi setup. And we can also notice that all the attributes are unauthenticated. The fourth one is signature, but it's not fingerprint. And so the evil twin attacker can just self-sign a certificate and spoof all the attributes. And it's even possible to make a stealthy attack where the server, where the client pins the attributes, and then next time is connecting to a legit setup, the user can connect with no issues, so no warning will be shown. And possibly the biggest problem here is that the system will forget the pin after you have failed the connections for a few times. So what this means is that the attacker can induce first use. So even though you have already passed your first use, so the attacker can force you into going back to first use again, then the attacker can perform the former for attack. So the next configurator that we consider is one by Edgeroam. So as you know, Edgeroam is this kind of network of Wi-Fi that you can use for universities. And they have designed two applications for Android, Edgeroam Cat and Get Edgeroam on Android that you can use to download pre-configured profiles from the Edgeroam server already. That is designed by the IT admins. And here, the server authentication attributes is embedded inside the profile. And so whether this configurator is secure depends on first how the IT admins define the policies and also how the policies are enforced in the applications. And our previous works has already considered the profiles, and we have found several issues. And so for this study, we are focusing on the enforcement. And so when we are, after we reverse we look at the source code, we found that the Edgeroam Cat app uses the old Android API method, set subject match, that can only handle one single server name. But usually multiple server names are desired because one organization can have multiple authentication servers with different subdomains. And so to address this, the app uses an improvised algorithm to compute a common suffix. So it peels off the leftmost subdomain, and then if the remaining suffix is shared, then it's going to use that. Otherwise, it's going to match every domain. What this means is that, for example, if we specify a.b.c and a.d.c, then the result will be empty. So it will match every domain, so every certificate works. And we try to target a real profile that has .at as the common suffix. And it also specifies a commercial CA, then we can actually buy a domain and a certificate from the same CA. And then we are able to perform the evil twin attack. And if the common suffix is loose and it specifies commercial CA as the root of trust, then the profile is vulnerable to this loose name matching attack. But worst of all, we also realized that set subject match performs a substring match instead of a suffix match. This means that, for example, again, if the profile outputs .at, then I can purchase abc.attacker.com, and the name matching logic will still accept that. And so, again, we target the same profile, and our attack is successful. For this attack, this just needs to have the profile just needs to specify a commercial CA as the trust anchor. So that's very powerful. So since then, they have also introduced this new application, Get Edgeroam, that uses similar but different logic. So it uses this set domain suffix match API from Android and the behavior depends on the Android version. So for Android 9 or below, again, it still only supports one single server name, and so they compute longest common suffix if you have multiple server names. And so we tried to look at different profiles, and we found one that specifies two server names, one domain and then one IP address. So the result, longest common suffix is empty. So again, we purchased a certificate from the same CA, and we got the Evil Twin working. So we wonder how many profiles are actually vulnerable to these attacks. So we crawled about 4,000 profiles from Eduroam, and we found nearly half of them use commercial CA as a trust anchor, and thus it will be vulnerable to the substring match problem. And for the common suffix matching problem, there's less, but still a few. So I will argue, we should argue that actually it's not entirely the developer's fault. The Android's API design should also take some blame, because before Android 4, there are simply no ways to set up server name checking. And since then, there is a set subject match used by Eduroam Cat that only handle one single server name, and it uses substring match. And only since then, since Android 6, we have new attributes that can support different kinds of name checking. So there's also Chrome OS, should be similar to Android, right? And it actually has built-in configurators that works on their custom profile format. And before the old versions of Chrome OS, there's again only subject match that can only accommodate one single server name in the subject, similar to Android. And actually, this also explains that in our previous work, we have noticed so many loose name matching in the profiles. Since then, there are two new attributes similar to Android, but it only checks the SAN instead of also the subject. And this is actually not conformant to the standard. The standard requires one of the subject and SAN to be matched, but using the attributes that we are given, we can only achieve a logical AND. We can only match for both of them instead of either one of them. So none of these attributes can satisfy the requirements by the standard. So finally, we have also played around with a proprietary Wi-Fi configurator. It's a SecurityW2 join now. It's similar to Eduroam in that it fetches or bootstrap pre-configured profile, and then you can use that for server authentication. So in order to understand how the application works, we use man-in-the-middle proxy to intercept it, and we have also tried to crawl some of the profiles to analyze. So we mainly investigated profiles that uses PAP or TTLS because TLS is involved. And we found that there is an attribute in the profile that will allow the server validation to just be disabled. This means that if the IT admins chooses to disable it, right, then the credential theft is indeed possible. And we wonder how many profiles are affected. So we found a little bit, about 10 of them are affected, but they choose to turn off the server validation. We also found an attribute that will allow the application to inject certificates into the trust of the system. So depending on the circumstances, this may allow some third party to inspect the TLS traffic of the user. And we hope that the organizations inform the users about this. There can be some issues if the users are not aware about this TLS interception. And we also found another issue that on Windows, if the profile specifies TTLS, it's going to offer 2 weak cyber suites in the TLS client hello. Both of them are considered weak because it doesn't have perfect forward secrecy. So only 2 cyber suites are offered. Both of them are weak. So obviously, we have to do responsible disclosure. So for the Android tofu problem, we have reported this, the trivial, the credential theft problem, the credentials sent before the prompt, right? This is reported to Google, and they acknowledged it and they fixed it. is going to be released soon, trademark. And for EduRoam, so the maintainers have acknowledged our findings, but they also note that since Android 8, they recommend Get EduRoam instead of EduRoam Cat. However, the EduRoam Cat is still available on Google Play and are still recommended by schools, so that's an issue. They also argued that the set subject match, substring match problem is known, and the official guideline requires the use of dedicated CA instead of commercial CA. But then again, from our crawling, we found nearly half of the profiles still uses commercial CAs as the trust anchor, so clearly they are not listening. But luckily for Get EduRoam, the longest common suffix problem, we found that the version on Google Play is a different version that is not vulnerable. For Chrome OS, we found an additional problems in the UI where the details you can find in the paper, and it's going to be fixed. And last of all, for Secure W2, we have reported the problems to the developers, and we will try to work with them to fix the problem in the future. And for the profiles, we have reported the problems of disabling server validation to the admins, and we received some responses. So in conclusion, we have investigated some enterprise Wi-Fi configurators. We have found design and implementation issues in all of them. So despite the ease of use, there's still a gap between the expectation and the enforcement of policies inside of these enterprise Wi-Fi configurators, and the threat of the evil twin is still not over. So lessons learned. For API designers, they should design carefully and understand real-world needs, because a wrong design can haunt for years. You can just look back at the Android and Chrome OS set subject match problem where they use substring match. It still works for the latest version of Android. For developers, they should adaptively use the best API method available for policy enforcement, because again, new OS versions should not suffer from old problems. Again, just look back at the set subject match problem. For protocol designers, we argue that tofu or tufu, that I will get into in a bit, plus pinning may be the better method for server authentication, because it doesn't need the scalability like in the web setting. So we argue that something else should be used instead. So about tofu, so we found, again, we saw that tofu on Android allows the attacker to induce first use again and again. And so, but again, if you use OpenSSH, when the system sees a different key, you are going to get a vibrant warning, and you as the user has the responsibility to reset the key instead of programmatically resetting it for you. So actually, we probably want this kind of trust only on first use term being used instead of trust on first use, tofu. So that's it. So any questions?
While we're waiting for questions, maybe I will start. Is there some sort of intrinsic reasons why all these Wi-Fi configurators get it wrong and make errors? Is this just programming errors, or is there something intrinsically hard of solving this?
Yeah, so I mean, there are a lot of aspects into making this Wi-Fi configuration thing secure. So obviously, you need the configurator to work properly, right? Not to do a substring mesh or those kind of stuff, right? And at the same time, the IT admins that design the policies should understand, should do the right thing to use, to have, for example, using dedicated CA to make the whole thing more secure. And obviously, the users needs to be educated, right? So there are a lot of aspects being involved. And obviously, the programmers couldn't do things well if the API doesn't allow them to, right? So the API developers also need to consider these requirements. Yeah. So there are a lot of aspects being involved.
And maybe as a follow-up question, is there also some configurator which does it correctly, or is it not available, or you didn't find one?
So I haven't looked into that many like other Wi-Fi configurators. So, I mean, for secure W2, I don't think they are doing too bad. But obviously, there is an option for the IT admins to disable server validation. I think that is that's not great, right? So because they advertise being more secure, right? So they shouldn't have this option. But other than that, I think they are doing a fine job. Yeah.
Any questions by the
I'm not advertising for them, by the way.
Okay, it seems not. Let's thank the speaker again.